guys. We are still continuing Algebra course, and this is lecture 5. It will cover integer exponents. Please, to see the other lectures, you can visit the playlist called Algebra Course Lectures. So this is lecture number 5, integer exponents. Later we can see rational exponents. Now let's start with the basic definition of the exponents that has the form a to the power n. This means a times a times a times a, n factors of a. So there are n factors of the a. A here is called the base. See the a, just know the word please, it's called the base here, a is the base. N is called the exponent. It is a positive integer here. So 5 to the power 4, 5 is the base, and the exponent is 4. So let's see a first example here. 1 over 2, half, power 5 means half times half times half times half times half. Just multiply 1 over 32. This is the answer. Here I put one simple, nice, easy example, little tricky, please. And be careful to understand this one here on the left. Minus 6 all squared minus 6 squared. Many math users, many students, they will write both are plus 36, and that's not correct. If you have minus, let's go second one here, please. Minus 6 squared. See the squared on the 6. So here the base is 6, not minus 6. See here the base is 6. So minus 1 is just standing there. There is a number minus 1 times 6 squared. This is what we see it, how we see it in math. So the answer here, minus 36. Do not be confused. Now look up now. Minus 6 in the bracket all squared. We say all squared. So it is minus 6 times minus 6. Plus 36. So you will say the only difference is the bracket? Yes, it is the bracket. If you have a bracket, minus 6 times minus 6. If you don't have a bracket, there is a minus 1 outside, and then 6 times 6. The answer is minus 36. Let's see, if the power is negative or 0, we have two rules here. Please be careful to understand them. So a to the power minus n, 1 over a to the power n. Anytime you have a negative power, and here is integer, a is a non-zero real number. So 1 over a to the power n. See simple example here. Somebody say find 4 to the power minus 2. Don't say minus 4 squared. Some students, they will say, I have seen, they say minus 4 squared. No, that's not correct. 4 to the power minus 2, 1 over 4 squared. See, the same base, the same power, 1 over 16 is the answer for this. Now, a to the power 0, any number non-zero to the power 0 is 1. I put here 4 examples so that not to be confused. 7 to the power 0, everyone will say 1. That's correct. Now, minus 7 to the power 0, you know now the trick. Minus 7 to the power 0 is minus 1. Because this minus is not in the base. Okay, let's look here. 6y to the power 0, and the last one is 5x all to the power 0. You see the difference here. 5x all to the power 0 is 1. But if you have 6, no bracket here, times y to the power 0. We don't have to write the times, but it's known. We say 6y to the power 0. That means 6 times y to the power 0 is equal to 6 times 1 is equal to 6. So be careful, please, about simple items here. Let's see more simple examples, 5 to the power minus 2, and here minus 5 to the power minus 2, minus 5 all to the power minus 2. 3 simple examples. If you have any confusion, please try to learn here. So this is straightforward, 1 over 5 squared, 1 over 25, simple. Now minus here, you see this minus, we don't have bracket. No one should tell you we have a bracket, you have to look. See minus, that means this minus is minus 1 times, but we don't write it in math like this. We know this is in our mind, we can see it like this. But this is the way we write it, minus 5 to the power minus 2. So I leave the minus 1 times 1 over 5 squared. So this is 1 over 25, and then multiply with the minus. So that's the answer here. Now, if I have a bracket, minus 5 all to the power minus 2. See, this all will come down in the denominator. 1 over minus 5 all squared, and this is bracket, that means 1 over plus here 25. Nice question. This is example 1. It's a little tricky, I think, this one. Very good idea. Now you pause the video, please, if you want to check yourself and if you want to learn more, and do this example. Now this is not a straightforward, not one number. I put here 5 numbers with different powers, and then you have to simplify the numerator, denominator, and then you will get the answer. I will do it in details in the next slide, but please get a piece of paper and try it yourself. Maybe 1 time, maybe 2 times. Check if you get the same answer, different answers. Okay, and now by this time, I think you have paused the video, you have tried. Let's go together and see. Now be careful about here minus. See, this minus is not in the base, so because no bracket. Here we have a bracket. Here we don't have a bracket with this minus. Here we have a bracket. And here we have 2 divided by 15 all squared. Now, let's see the answer, 9 over 32. Anyone get this answer? 9 over 32. Let's go in details here. Minus 2 to the power 0. Okay, we know that is 1. Minus here, see, we have a minus 1 over 2 cubed. See, minus 1 over 8 now. We finished now the numerator. You see, this numerator, minus 1 over 2 cubed times 1, minus 1 over 8. Leave it now. And then you have to use this formula. You have seen it many times. Division of 2 fractions. A over B divided by C over D. Leave the first fraction. Multiply by the reciprocal of the second. Now let's go here. Minus, there is no bracket. You see, 5 power 0 is 1. So minus 1. Minus 5 all squared, 25. Now this one we have to distribute the power here. 2 squared, 15, I can make it prime numbers. 3 and 5, each one squared. See, I can cancel now 5 squared with this 25. You see the idea here? 25 and here 25. 2 squared is 4, 3 squared is 9, and there is a minus. So now the whole answer in the denominator, after you simplify everything, you should get minus 4 over 9. Now let's apply this division of 2 fractions. Minus 1 over 8, the reciprocal here, 9 or minus 9 over 4. You can put the minus anywhere. Minus with the minus will go. So the final answer, 9 over 32. Try to make the answer as simple as possible. Okay. Now let's see the laws of exponents. See, I put here 1 in the laws. That means we have another slide, 2. So here the first 4 are the most important. And I think everyone knows this maybe from high school or before high school. Let's see, a to the power m times a to the power n is equal a to the power m plus n. What does this say in English? We say if you multiply 2 exponents with the same base, you can add the power. Again, so when you multiply That's one condition. Also, you should have the same base, second condition. Then you can add, like simple example here, 6 cubed times 6 to the power 4. See, this is multiply, that's the first condition. 6 and 6 is the same base. Now you can add the power, 3 plus 4. So the answer here is 6 to the power 7. If the bases are different, you cannot multiply, you cannot add the powers. Second one, when you divide, see that's the first condition, divide the same base, second condition, then you can subtract 12 to the power 5 divided by 12 squared. So 12 to the power 5 minus 2, 12 cubed. Number 3, law number 3. When you have two powers here, two powers, a to the power m, all to the power n. You should have a bracket here. Then multiply the powers. So 7 to the power 5, all to the power 4 here, you get 7 to the power 20. Now, when you have AB all to the power n, see the condition here in number 4, you should have a multiplication. You see, AB means A times B. We don't have to write the times. AB, just by mentioning AB, that means A times B. We can split here and distribute the power, A to the power n, same power, B to the power n, like this one, 10k. 10k is a product, you see, 10 times k. 10 cubed, k cubed. Now, if you have a plus, you cannot distribute the power. Remember here, if you have a plus, you cannot distribute the power. Now, I put some common math errors. You can check them in the playlist to see the mistakes that some students can do there. Now, let's see number 5. A over B, see division all to the power n, A to the power n divided by B to the power n. This is simple example, 5 over 6 squared, 5 squared divided by 6 squared. Now, if you have a fraction with a negative power, you can invert the fraction and leave the same power. See, A over B becomes B over A with this minus. Because when you have a minus, then you will say 1 over. That means you flip the fraction. Also, when you have A to the power minus n over B to the power minus m, you can take this B up. It becomes B to the power m, and this one A to the power n down. But remember, you have to have multiplication if you have more than one term. I think, let's see example, 2 parts. Let's see the first one. AB to the power minus 4, all divided by AB all to the power minus 3. The first one for sure is easier than the second one. But you can try each, please. You can pause the video for seconds, some seconds, and try this one. This is very simple. Number 1, I will show directly. So, B to the power minus 4, 1 over B to the power 4. And this one, 1 over AB all cubed. So this becomes A over B power 4. And this becomes 1 over A cubed B cubed. Now we have 2 fractions. You can go back to this formula here to use it. You see this formula, you can use anytime you have division of 2 fractions. You should never forget this formula. Okay, now A over B power 4. Let's see the reciprocal here. A cubed, B cubed over 1. And we cancel B cubed with B cubed here. We are left with 1B. A times A power 3, we add the power because we have the same base in multiplication. So the final answer, A power 4 divided by B. I will advise you to try number 2, please. Very similar to number 1, but more challenging. X squared over y power 13, x cubed over y squared, all in the bracket power 4, minus y cubed x all squared, minus y power 5, x power 4 all cubed. Too much, too many powers there. Try it, please. Okay, I think now you have tried, or some of you have tried. Let's see this second one. This is the second one. Oh boy. Minus x to the power 28. Minus x to the power 28 is the answer. And it's only 2 lines. You can do it. Let's see. All right, leave this one here, x squared y 13. Here, distribute the power. You see the power here, x cubed, so this x power 12, y power 8. Look here, we have how many numbers you can see here? See how many numbers? Many students answered before when I asked them, they say, I see 2 numbers. No, no, no. I see 3 numbers. I can see it from here. 3 numbers. That's minus 1. You see minus 1 here. Y cubed x. Each one squared. So minus 1 squared. 2 times 3, 6. X to the power 1, 2. Here, how many numbers I see? 3 numbers. Minus 1 cubed. Y power, multiply 3, 5, 15. Multiply 3, 4, x power 12. Now, the simple numbers are this one, minus 1 squared. That's plus 1. So it will disappear. Minus 1, all cubed. Minus 1 times minus 1 times minus 1 is minus. So we have a minus in the answer. Now here, when I multiply the first 2 numbers, x squared, x power 12, I put x power 14. Here, y power 13, y power 8, I add y power 21. Now look at the y's here, y 16, y 15. Also, I can add these 2, y power 21, it will be cancelled. And x 12, x 2, so we can add x power 14. Now you can add x power 14, x power 14, x power 28. So the final answer, minus x to the power 28. You can, let me tell you something here. You can add all the x's up one time. It will be 28. You can do that. You can add all the x's in the numerator. And then here all the y's in the denominator. Then y power 21, y power 21, they will be cancelled. This is the answer. I hope you enjoyed this question. Let's see another one. Oh boy, example number 3. Let's simplify the expression, please. 3m squared all to the power minus 1, 3m to the power 5 all to the power minus 2, divided by 3 to the power minus 1, m to the power minus 2 all squared. Please, you can pause this video for a little and try it. And try to compare the answer on the next slide. Let's see. Okay, I think now you have tried. Let's see all together. 1 over 3m to the power 8. I think many of you, they get the correct answer. 1 over 3m to the power 8. Let's see the first one. Just distribute the power. You see idea? Leave all the negatives, leave all the positive powers, just distribute. 3 here, you see 2 numbers here. 3 power minus 1, I write it there. M power minus 2, I write it there. 3 power minus 2, m minus 10. 3 minus 1 squared, so 3 power minus 2, m to the power minus 4. Now I combine here. What do I combine? See, I canceled here. 3 power minus 2, 3 power minus, I can see this is the same number, cancel it. Any number up and down, the same number. But remember, you have to have multiplication up, multiplication down. You can cancel. So you are left with 3 power minus 1. Now you can add the power here. minus 2 minus 10. You add the powers there, minus 12 when you add. Here, minus 4. Now, when you have division, remember formula number 2, law number 2? Division, you subtract. Minus 12 minus minus 4. So minus 8. Now, look at the answer here. Usually, you have to leave the answer in positive exponent. So this is altogether 1 over 3 m to the power 8. Now, this is very similar to example 3. This is try at home 1. You can try it at home. And then the answer here, only x power 8 divided by 5 squared, which is 25, y power 2. If you need the complete solution of these try at home or extra questions, you can look for other videos, integer exponents, extra questions. Now, let's look at this example 4. Nice question. Evaluate the expression a plus b all to the power minus 1 plus a minus 1 plus b minus 1 all to the power minus 2 after you add inside. If a is equal to 2, b is minus 3. So I gave you the values of a and b. It will take time. Medium. This is a medium question, I think, because we have sometimes simple questions, medium questions, and little challenging or difficult questions or not easy. Let's see. This is very nice to try on a piece of paper to learn more and to see your mistakes if you have any mistake in this question. Okay, I think now you have tried. Just replace A2 in the expression here and replace B minus 3. Then you have to add inside the big bracket. See, the big mistake some students will do here, you cannot distribute the power here when you have a plus. That's the big mistake you can do here. You cannot distribute here the power. Also, you cannot distribute this power because we have a plus. So you have to add here inside, and here a power minus 1, only 1 over a inside. Let's see, the final answer for this, I think many of you will get the correct answer. 36 divided by 25. That's the final answer. Let's go in details here. 2, this is a, and b is minus 3. You see a plus b. So directly you can write 2 minus 3. See, minus 1 is there. To the power minus 1. See, nice number. Minus 1 to the power minus 1. Now, 2 power minus 1 is half there. Minus 3 to the power minus 1. 1 over minus 3, which is the same as minus 1 over 3. That's the important part here. See, this minus 1 to the power minus 1, 1 over minus 1. But it's better and easy to leave all the denominators, see here, very clean. See this one here in the middle? Denominator 1, denominator 2, denominator 3. Leave all the denominators, I advise you, as positive. So you can take the minus up. Easy, you can take it in the numerator. Now you have, see, the whole question now is 3 fractions here. Minus 1 over 1 plus 1/2 minus 1/3 all to the power minus 2. Look here, please. Minus 2 in the question. Here we did not touch it. 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 Here we did not touch it until the last step. Minus 2. See, in the power minus 2. What do we mean? Invert the fraction and square. Invert, square. If you have minus 3, you invert and cube. Now you need LCD here. This is easy question. Multiply here by 6 up and down. Here multiply by 3 up and down. Here multiply by 2. If you need to know more about LCD, more difficult questions, there's a separate video about fractions LCD. You can go there and see it. Now, this is try at home, similar to example 4. P, I give you minus half. This is P here, remember. P is not there, this is Q. So P here minus half. Q here is 1 over 3. R minus 1 over 4. This is more challenging. But at home, at your leisure time, you can put these numbers as fractions, minus 1/2, 1/3, minus 1 over 4, and do the value for this expression. Only I think I will give you the answer, 17 over 33 is the answer. So you can check it. If you need the detailed solution, all the steps, you can check the video on integer exponent extra questions. Now, extra question. This is another extra question. Let's try it. We will do, I think, all the details here. Minus 2 to the power minus 2 plus 3 to the power minus 1 all to the power minus 1. A good idea, pause the video, try it on a piece of paper, then directly we will go to detailed solution. I think you have tried now. I hope. What do we do here? Minus 2. See, the minus here is not in the base. So we leave it here. See, we leave this minus. 2 to the power minus 2. Did you get 12? The answer is 12. Okay, let's see. Minus. See, I leave this minus. 2 to the power minus 2. 1 over 2 squared. 3 to the power minus 1. 1 over 3. This is 4. So minus 1 over 4 plus 1 over 3. Again, we need to add the fraction. See, I leave, look here, the upper power, minus 1, leave it minus 1, leave it minus 1, leave it minus 1, leave it minus 1 to the last step. Just before the answer, when you have one fraction, you just invert. So here the LCD 12, I have to multiply by 3 up and down, here multiply by 4. So minus 3 over 12 plus 4 over 12, same LCD, now we can add. See here we cannot add because the denominators are different. We have to make the same denominator. How do you make same denominator? If we have to add or subtract fractions. So minus 3 plus 4, 1 over 12, all to the power minus 1. Invert 12 is the answer. Now, extra question number 2. Given, this is not easy question, 3 to the power y is equal to x. Find 9 to the power 2y minus 1 in terms of x. I give here as a multiple choice, A, B, C, D, E. The answer is one of these. Now you cannot choose the answer unless you do it. You have to start with this one, simplify here, use the given. See, the given is given so that you can use it inside the question. And then you should get x power 4 over 9. So the detailed solution, if you need the detailed solution, you can check other videos on integer exponents, extra questions. Now, let's find the value of this. 0.25 all cubed, 80 all cubed, 0.5 all squared. I think it's a nice question. We need one number. One number, the answer can be any number. All right, let's see. Can you try it, please? I would be happy if you try it, because if you get the correct answer, that means you are good in math. If you get a mistake, you can learn more and better. Try it. Try to get this habit. When you see any question, pause the video, take a piece of paper and a pen or pencil, and then try it. Let's see. Try to find two different methods. I give you the answer here. Only 2,000. Did you get this answer? use the rules of exponents in method number 1. Another method, different method, you will get also 2000 because we have the same question, same answer, 2 different methods. If you get one method, it's okay, good. But if you try 2 different methods, it will be better. To see these 2 different methods in details, go to another video on integer exponents, same video with all these questions together, done in details. Now this is lecture number 5. Now let's do this one here, 0.25 cubed. Same question, but I changed the idea. 0.25 cubed is equal 80 cubed, 0.25 squared. Suppose this one is equal 2 to the power m times 5 to the power n. Find m plus n. See, I changed the question, the idea of the question, but inside the details, it should be the same. I did not say, see, in the other question I said, I will show you. Find the value. You see, this is extra question number 3. This is the same question. I changed the idea. Find the value, just find the value. It will be 2000. Now, in this one, try at home 3, find m plus n. Now, what is m? M is the power on the 2 after you simplify all this, and n is the power on the 5. So you have to play with the numbers. In math, we say, play with the numbers. See, I will put you the details, all the details here, the solution. See, from extra question number 3, we get this one here, 2000. Now you should get 2000 there first. So you should do extra question number 3 before you continue. Now let's play with these numbers. 2 is times what? 2 times 1000 here, see, 10 cubed. 2 times 1000, 1000 is 10 cubed. I know 10, 2 times 5, all cubed. Then I distribute the power here, 2 cubed, 5 cubed. Here I add the power, you see 2 power 1, 2 power 3, I add the power, 2 power 4 times 5 power 3. So if you compare this to this, you see, compare this to the given here. What is m? M is in the power, only 4, n is 3. So when you add, the answer here is 7. That's m plus n. Okay, this topic is to be continued in lecture number 6. So there are 2 lectures, 5 and 6, the same topic, integer exponents. Thank you for watching. I hope I can see you in another video with another topic. And this is, again, I'm reminding you, this is lecture number 5, integer exponents. Thank you very much.